Hi, this is Sung from Sky Academy, and in the first episode we started off with the basic form of a circle, the equation of a circle, where the center was at the origin, right, and the radius was r units, and we said that it looked like this: x squared plus y squared equals r squared. All right, so you've got the basic circle, which is over here, and what we're going to do now is we're going to shift the circle left, right, up and down, okay, and we're going to make the center not 0, 0 as it is here, but let's make it, for example, HK, right, where it's h units, like a generic h units to the right and a generic k units up. All right, and if h and k were negative numbers, they'd be to the left and down, right? But we're going to treat them as though they're h and k units to the right and up. Okay, cool. So what that would mean is, in order to shift the circle h units to the right, instead of moving the circle h units to the right, we're going to move the number plane h units to the left. So in other words, the x value will have to shift to the left, and we do that by minusing h from x. So now with center hk, it's going to be x minus h squared, and the reason it's minus is because x has to be that much bigger to compensate for the minus being there, right? So x has to be that much bigger. So in other words, each point on the circle would have to be h units bigger, and bigger is to the right. All right. So minusing h from the x will necessitate x to become bigger. Yes, and as well, minusing k from the y would make y compensate by having to be bigger and shifting the graph y units up. Okay, so now with center h and k, the graph becomes x minus h squared plus y minus k squared equals to, now we haven't changed the radius at all, so the radius is still going to be equal to r squared, right? And that will be the new graph, okay, or the new equation for the graph of a circle, or for the circle that shifted h units to the right and k units up. Okay. So let me just say that again. This point needs to be h units bigger to the right, and we do that by minusing h from the x, so that x has to be bigger by h units to compensate, right? And y, we do the same with y by minusing k, which will shift the graph y units higher. Okay, cool. Now, the sort of question that you're probably likely to get with this sort of with circles with centers that are not at the origin, you'll get one long algebraic expression, and you'll be required to work out where the center is and what the radius is. I'll put an example up on the board. Okay, so I'm going to press pause now, and once I've put that example up, we'll look at that together. Alright, thank you for watching. We'll look at two specific examples, alright, and this is the sort of typical question that you might be asked. You might be asked to find the center and the radius of an equation that looks like this. Now, when you see the fact that it's got an x squared and a y squared in there, you should automatically think, well, alarm bells, this is going to be a circle, right? Won't always be, but in the 2-unit course it will always be a circle. So x squared and y squared, followed by x and y terms, it'll be a circle, right? And so the next thing you have to do is work out the center and the radius. This is where quadratics will come really handy, and in particular, being able to complete the square is going to be particularly handy as well, all right? And I'll show you what I mean by that. x squared, I'm going to group the x terms together, and I'm also going to group the y terms together, equals to 0. Now what I'm also going to do at this stage is work out what I need to add here to make this a perfect square. Right? So if you want to go back and look at the quadratic section where we kind of covered this, to make a perfect square, you halve the middle term and then you square it. Okay? So halve 8, which becomes 4, square it, you add 16. Yes? Halve 6, which becomes 3, you square it, becomes 9. So you add 9. Now if you add 16 and 9 to the left hand side, you've got to do exactly that on the right hand side. So you end up with on the left hand side, on the left hand side still, and that gives you 25, right? Now this is a perfect square. It ends up being x plus 4 squared plus x minus 3 squared, and 25 is 5 squared. So your center, according to this, okay, is negative h. Well, x would have to, so h would have to be negative 4 if you're minusing h from x, right? Center would have to be negative 4, positive 3, and the radius would have to be 5. Does that make sense? Cool. So you've got to be able to do these sort of questions, okay? And then I'll give you another example, all right? And this is an example where you only have to work out the, in this case, the horizontal displacement because there's no vertical displacement. Okay? So let's have a look. Group the x's together. So x squared minus 10x plus y squared equals 2, and then you bring 24 over to the other side, minus 24. Yes? Now, what do you need to do to make this a perfect square? Halve it and then square it. So halve 10x, which is negative 5x, sorry, negative 5. Square that, you're adding 25. Okay? And if you add 25 to the left hand side, you've got to do the same to the right hand side. Which becomes one perfect square plus another perfect square. Negative 24 plus 25 is 1, right, which is just 1 squared. Work this out. X minus 5 all squared plus y squared equals to 1 squared. So your center is going to be 5 and 0 in this case. And your radius is going to be 1. Okay? So make sure that you can see how this works algebraically and that you can do something similar if you see something similar. And then, of course, you need to be able to graph that as well. Okay? Cool. And to graph that, you just put the center in the number plane first. And then you graph the radius around the center. Okay. Thank you very much for watching.